everyone. So before we start, I have a question for everyone here. Have your users ever used a password more than twice? Uh, got their password stolen? Maybe they got phished, or maybe they forgot their password only to reset it again and again. If you said yes to any of these questions, WebAuthn and Passkeys are for you. This is our agenda today. We'll talk about why we should use Passkeys, how does it work on a high level, and how we adopted it in Mercari at a large scale in Japan. A bit about me. So I'm a platform engineer at Mercari Japan, and I've been in Japan since last 1 year and 1 month. And I also do some photography and gaming as a part-time hobby. So let's start with the standard itself. WebAuthn standard is what governs the Passkey implementation, and it is a set of technologies that enables passwordless authentication. It stands on three principles. It is a strong, that is the authenticators by which users authenticate generally are protected by biometric level stuff like fingerprint or face ID. It is scoped, that is the credentials created via WebAuthn are bound to the origin of the domain basically. That means that if a passkey was created for example .com, it cannot be used for example to.com. That basically eliminates the phishing vector. And it is attested, that is when a user registers this passkey, the authenticator also gives attestation certificate to the server through which the server can verify if the passkey is coming from a verified source or not. So why passkeys? It is most widely adopted WebAuthn implementation, and it can replace passwords and MFA altogether in most cases. Sometimes you might require something else than passkeys, but in most cases it's enough. It is phishing resistant by design. That is, as I said, it is bound to your device and it enables biometric authentication. That means if your server is getting passkey as authentication, that means it is almost guaranteed that it is the user who is authenticating. It is widely and natively integrated. It is supported in all modern browsers and also on all modern and popular OSs like macOS, Android, and Windows. So let's jump on to how does it work. On a high level, in any passkey transaction, there are two entities involved, the user's device and the auth server itself. So how does registration work in passkeys? First, the user's device, it will make a request to the auth server that, hey, I want to create a new account. And auth server will ask for a public key from the user's device. This is how it looks like. It's basically an API call where the auth server will return an options object, which conforms to the WebAuthn implementation standard. You might notice there is one thing here, that's RPID. This is an important thing. It's called relying party, which is a domain suffix against which your passkey is registered. This is what prevents phishing. So you have to make sure that this is the root domain of your website so that it can be used on any of the subdomains there. So once the options object is in the user device, it can create a key pair with hardware security inside the device, and it will store and generate and store the new key pair into the device keychain. This is where we will use the WebAuthn credentials API, especially the WebAuthn credentials create API with the options object that we got from the API call before. Once this credential is created, we'll get a public key that we can send to the auth server, and it will store the public key in the database for the authentication. And it will again be an API call basically to the server. So once the passkey is registered, when a user tries to log in, they will again initiate an authentication request. And this time the auth server will return a request plus a unique challenge for that particular session. And it's again an options call, just like the registration when we started the registration. And this time also we will pass in the RPID. And when the user's device gets the option, it will sign the response with the private key that was stored in the keychain, and that private key is retrieved by a, let's say, biometric authentication in Apple devices and stuff. And that can be done using the credentials get API, which will take the options object that we got from the auth server. And then we will send the signed response back to the auth server, which will validate the responses in the public key that we stored during the registration. And it will return 200 or 401 based on the validity of the response. Yeah. And yeah, that's it. So before jumping on the next section, I wanted to quickly share the Passkey adoption among Mercari users. So we started adopting Passkeys in March 2023, and as of June 2025, we right now have 10.4 million registered Passkeys within Japan. So what worked for us to get this large scale of Passkey adoption? The first was UI UX considerations. So one of the good features of Passkey, they have something called conditional UI, which prompts Passkey sign in if the device already has a Passkey registered. And what we did is we triggered this the moment our login page loaded. And we also added a sign in with Passkey button as a fallback on our login page. This is a short demo of how the conditional UI looks like. So on the Mercari login page, whenever you click on the email text box, you will directly get the use Passkey prompt. And within 3 clicks, you are essentially logged into the app without any need for password typing and stuff. And it is secure by default. Some more UI UX considerations include Passkey enforcement. So we basically enforced Passkey only sign in for accounts that have Passkey. That made the account secure by default. We also had Passkey registration prompt after sign in. That is, if a user does not have a Passkey registered before, they would get register your Passkey right after their login. You can also do this right now using the native conditional create API. So just like conditional login that we saw here, the credentials.create also has a conditional mediation now. So whenever a user logs in, the authenticator itself will prompt for a Passkey registration. We also use synced Passkeys. So before we saw that the Passkey credential was stored on the device keychain. But in this case, it is stored in a credential manager that lives in the cloud. This enables the Passkeys to be accessed across devices, and there is no need to re-enroll devices in this case. And it is generally available in modern iOS and Android OS in a native way. This is the state of the sync Passkeys as of November. So Apple devices supported by iCloud and Google devices supported by Google Password Manager. For any other devices, you can use the 1Password or LastPass or something like that to enable sync Passkeys. We also added fallback or recovery options because we had cases where users lost their devices and they could not log in. So we enabled multiple credentials per account, that is, users can basically register multiple devices. We added fallback options like SMS OTP, email link sign in as well. They are less phishing resistant, but they were needed because Passkeys was not exactly accepted initially as much as we expected. We added a bunch of account recovery choices for users with Passkeys, like verified email. And this year we also introduced a recovery using My Number card in Japan. So now if you lost your Passkey, you can create a new Passkey using a My Number card here. During the adoption of Passkey, all the features that we released was done using phased rollouts with a 5%, 10%, 20, and then 100. That's where we collected users' feedback and stuff. For every change inside Mercari or outside Mercari, that is on a standard level or an OS update level, we had to clearly communicate with the users because the UI is half controlled by us and half controlled by the OS itself. And we also had to internally be up to date with the behavior among new OS versions. So iOS 26, they introduced a whole new UI for Passkey prompt. So we had to make sure that that was communicated. Before wrapping up the presentation, I wanted to share some technical considerations as well here. The first thing that we faced was a lot of cross-platform or browser issues. Like, for example, this is just one example, like conditional mediation is supported only in Safari 17+. So you have to make sure to check before triggering any WebAuthn API if it is available on the device or not. For example, in this case, you can use the function here. Incognito tabs suppress passkey prompts, so you need to make sure to design your UI that you have to expect that the passkey prompt will fail, even if it is available. The relying party, if you remember the root domain on which the passkey was created, you need to pick a shared parent domain so that because the passkey is once created on the user side, it's very hard to delete it essentially because it's stored on the user's device. So you need to pick up shared parent domain and pick and pin it early because in future it's very hard to change that. Options caching. So just a recap, if you remember, whenever you started registration authentication, we fetched the options object from the server first.
Sorry, we are only 1 minute.
Okay. So I'll just fast forward. So we need to cache the options here because when the user clicks the button and the credentials API call is done, if we fetch the options in between that, it gets lost due to browser security rules. And at the last, we limited credential registration using the exclude credentials API, where it prevented duplicate passkeys in the same device. So this is a brief recap of what we talked today. We talked about passkey adoption, API implementation and flow, the scale and operational best practices, and the nuances that we faced on the technical side. Thank you for listening.
Thank you.